I recently got this Keithley 2602 Sourcemeter unit, SMU. It was defective and also not cheap. Let's see how it behaves. When I enable a channel, it shows overflow unless I manually range up a bit, and then I see some floating voltage around -2 volt. I thought it was very strange that both channels reacted essentially the same. My confidence level dropped when I saw the loose fan bracket here, usually a sign that someone else was in here and gave up. Luckily, no missing parts and nothing really obviously destroyed. Inside, the main power supply is an off-the-shelf TDK Lambda 24 volt, 150 watt. Caps looked healthy and load test was good, so that was probably not the problem. The DC-DC board has 2 separate channels, one for each SMU board. And each channel generates 2 independent sets of rails, very much like the previous generation 2400s, but with different levels, and they all looked fine. On the main PCB, there's a sizable FPGA, a cold-fire microcontroller, some RAM, flash, bunch of switching regulators. All the labeled test points for supply rails were clean. Top right, the unpopulated footprint, that would be an Ethernet controller right next to its jack. And in fact, the next generation 2600A does have network support. But I spent quite some time poking around the firmware, and I haven't seen a single trace of any networking code. My guess is at some point during development, they probably just abandoned net support for that. For this series. I'd be curious to compare this the 2600 to the 2600A mainboard. If anybody has good pictures, please share. Next, the SMU boards. There's also a big FPGA that controls everything. Voltage reference up here. 2 16-bit DACs here. For ADC conversion, as far as I can tell, it's some sort of integrating architecture. There's these 2 LT1116 fast comparators, and they're pretty busy during normal operation. There's some ramps on the inputs and fast pulses on the output. Middle section and along the bottom edge, that would be the power section. And far right, near the output, the core of the analog black magic with a maze of PCB cutouts to control leakage. Some factory bodges here. Speaking of bodges, while I was gathering info and resources, I came across this EV blog thread by user TheSteve. His board had what appeared to be probably a factory mod here. These two TO92 standing up on SOT23 pads. And on my board, these were the original SOT23. That's Q31 and 32, and that's plain MMBT 3904 and 06. I'm not mistaken. Naturally, I suspected this area first. I was rewarded with one PNP with an open base-to-collector junction. Later, I found the exact same fault on the other channel. I shamelessly did the same TO92 bodge as the factory with some parts I had on hand. It took a bit of finesse to get it to fit right underneath the fan, and that was it. Everything was back to normal. There's some speculation about the purpose of that bodge. I would find it very odd if it was a matched pair because, well, first of all, why use discrete parts? They're pretty low grade 3904s? Why not like two transistors in one package? They're not even mounted close. They're not thermally coupled. During operation, also they're both biased and conducting, so I don't think they're selected for low leakage. And from probing around, it looks like this is part of the early stages of the power amp section, and that's like comfortably inside the feedback loop. So I'm not sure what kind of characteristic they'd be optimizing for there. So my guess is mostly for dissipation. They do get warm even at idle, and maybe it was marginal with the SOT23s. The loud fans are loud. The 40 millimeter fans inside the SMU boards had worn bushings and were just awful. A little drop of oil was helpful, but that wasn't going to be a long-term solution. I replaced them soon after. Pro tip, look at the drawings before you order a replacement. I didn't, and I didn't notice there was the original fan had a countersink on both sides of the mounting holes, so I had to drill those out manually, because if you don't, well, then you don't get the proper mounting height on the threaded studs. I always like to dump all the things, and each SMU board has its own calibration EEPROM here. If you disconnect the ribbon cable and power on the machine, the FPGA doesn't get configured and stays in the default or reset state, and then that lets you hook up and dump the EEPROM in circuit. For dumping the mainboard flash, I did the usual deep dive inside the firmware using an update file first. This went pretty well. I found a few secrets while digging around. I found this function memread and used that to dump the actual contents of the flash. And there's a few pages that contain some parameters, serial numbers, config. Yeah, that's just like your non-volatile settings right there. Also came across some commands that read calibration constants, get cal v, and so on and so on. And I made a little rough script that goes through all the ranges on both channels and retrieves what it can. It wasn't entirely satisfactory, and I go into some detail on my website. I also found a credits command that loads a massive Lua script, and that loads some sort of animated text. And you get to that by holding channel A limit and trig while powering on. And then in the factory scripts, select credits and run. And on that note, greetings to the firmware team, and thanks for watching.